Alright, so 3-2 says we're going to combine like terms with distributive. So today we're going to be able to use the distributive property to simplify expressions and differentiate between commutative, associative, and distributive properties. So there's these three properties. We've already talked about commutative. Commutative means to move. Associative means to group. And now distributive means to go like pew, pew. It's our pew pew property. Pew, pew. Okay, and we'll be able to justify our steps. Okay, so Mr. Sayers thought he had enough chairs. He had 7 groups of tables with 4 chairs. Okay, so 7 groups. 1, 2, 3, 4, 5, 6, 7. He started each with 4 chairs. So I'm just going to use a highlighter. I'm going to say there's 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so he started off with 4 times 7 would be 4 times 7 would be 28. So he started off with 28 chairs. And he had to add 2 more to each table. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So that'd be 2 more for each 7. So 2 times 7 would be 14. So 28 plus 14 would be 42, I think. Or he could have just said that, oh, there's 6 at each table. So now I have 6 for 7 groups, so 6 times 7 is 42. Just depends on how he counted it. If he counted it first and then added 2 and wanted to just add those extra ones. Okay, this one says Mr. Tyson thought he had enough chairs. He had 5 rows of 6 chairs. Okay, so 1, 2, 3, 4, 5, 6, and he had 5 of those. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So right now he has 30 chairs. Okay, that wasn't enough. He needed to add X amount. So we're not sure how much he needs here. So we're not quite sure. But we're going to be adding it on to each row. And it could keep going on and on. So there could be 3, there could only be 1. We're not sure, an X amount. But there's 6 here, and it goes X across. So a way we could express that is if I have 30, I would add on 6 times whatever this X amount is. Okay, that'd be if I counted my 30 chairs first and then added on the extra. But if I wanted to know exactly how much, I'd start with the 6 plus X. Oh, not 6, 5. 5, sorry about that. 5x. And we would multiply that by 5. So this is called the distributive property where we give each part that 5. 5 times 6 is 30, and 5 times x is 5x. So here goes our first one. We need to simplify this expression, and right now I can't simplify because I can't do 2x plus 7. So that won't work really well as I can't do 2x plus 7. They're not like terms. What we can do is distribute. So distribute, I like to make this fun sound. It goes pew, pew. Okay, so that means I'm going to take that -6 and give it to each part. So I'm going to do -6 times 2x and then -6 times 7 because it goes to each part. So now we can multiply. -6 times 2. 6 times 2 is 12. Negative times positive is a negative. And remember, you can use a calculator for this if you'd like to, but we do have to keep that x. So -12x plus Negative 6 times 7. 6 times 7 is 42. And negative times a positive is a negative, so negative 42. And there are no like terms. I have one part that has an x and one part that does not have an x, so I cannot add them together. So that's our final answer. Okay, number 2, we're going to distribute. So to distribute this, I have to give this negative 3 to each part. So I'm going to go pew, pew, pew. So I have negative 3 times that first part, 4x, plus negative 3 times the second part, which is y. Now I'm going to think about this as a negative, so plus this negative 3 times that negative 3. So now I'm going to multiply because that's what my order of operations tells me to do. Before I add, I have to multiply. So negative 3 times 4 would be negative 12. We keep that x. Plus negative 3 times y would just be negative 3y. Plus negative 3 times negative 3. Negative times a negative is a positive, and 3 times 3 is 9. Are there any like terms? The answer is no, because I have an x, a y, and a 9. So that would be my final answer. All right, second page. Cruising, cruising. All right, so on this one, we're going to distribute. Now this time, I can only distribute to what is inside my parentheses, which is a 5x minus 12. So those are the only terms that are going to get that 4. Pew, pew. So I'm going to do 4 times 5x plus, and then again I'm going to think about that as a negative. 4 times negative 12. Because this 7x wasn't included in the group, they just hang out by themselves. Okay, so now I'm going to do that multiplication. So 4 times 5 is 20, so I have 20x plus 4 times negative 12. I would use a calculator. 4 times 12 is 48, negative 48, plus 7x. So now are there any like terms? Well, indeed, there is this time. I have an x here and an x here. So the answer is yes. We have x's. Okay, so I'm going to put those by each other. I can use my commutative property. So I can do 20x plus 7x, then plus negative 48. So 20 plus 7 is 27x plus negative 48. Now I can't combine that 48 and the 27 because the 27 has an x and the 48 does not. Okay, the reason I couldn't just add the 5x and the 7x was because I had multiplying here. Okay, with the multiplying, I can't use the commutative property. Commutative property only works with addition. Okay, so this one we're going to simplify the expression and justify the steps. Oof. Okay, we always start with our given. So we're going to start with 3 times 2x plus 4 minus 7 times 9 minus 3x. Okay, and that's our given. So first thing we're going to do is distribute. We're going to go pew, pew. And we're going to think of this minus 7 as a plus negative 7. Pew, pew. So this is really 3 times 2x, and I'm writing small on purpose because we're going to write here our simplified part, plus 3 times 4. And that 3 only went to this, what's inside these parentheses. Okay? And then this negative 7 goes to what's inside these parentheses. Okay, so plus negative 7 times 9 plus negative 7 times negative 3x. Okay, so that's our distributive property. Now I'm going to actually multiply 3 times 2 is 6, so 6x. 3 times 4 is 12. Negative 7 times 9 is negative 63. And negative 7 times negative 3 would be positive 21x. So now, are there any like terms? And the answer is yes. Okay, if I use my highlighter to show my like terms, I have a 6x and a 21x. And then I also have a positive 12 and a negative 63. So I can combine those. Before I do that, I'm going to put them next to each other. So I'm going to have 6x plus 21x, then the 12 with the negative 63. I'm also going to group them as I do that. So that is both the commutative and the associative. First we did commutative, we switched it around, and then we also put parentheses. So now we are going to simplify. So to simplify, we are going to do 6 plus 21. 6 plus 21, those are the coefficients, would be 27. So 27x plus 12 plus negative 63. We could use a calculator. They're different, so I subtract. 3 minus 2 is 1, 6 minus 1 is 5, and I definitely have more negatives. So negative 51. And that's it. Okay, so we're going to, distributive property says if I have A times quantity B plus C, I can do A times B plus A times C. So I distribute. Pew, pew. Okay, and we're always going to change subtracting to adding the opposite. Okay, and that is it.